Welcome to MRU E-Learning powered by Malaradi University. This is Danda Supriya from Department of CS and IoT. Welcome to the session on raw data to reliable models, data pre-processing techniques in machine learning.
We will be discussing how
data
to meaningful
will be
insights
converted to meaningful
and how are they
insights
useful for machine
and how
learning
are they useful
predictions
for
and
machine learning
classifications
predictions and
classifications in this session.
I'm going to discuss why significance of data pre-processing, what is the critical phase we have in machine learning modeling, and how can we extract meaningful patterns from the data for predictions and classifications. For example, we have a data set, then we have a goal that is like you want to predict house prices based on the data, or you may be working with some credit card fraud detection, or you want to analyze the data and to give the classification like whether a patient is suffering from any disease or not. For all such purpose, first of all, what we do, we will be gathering the data from various data sources. But the data which we have in these data sets may not be consistent. That means it may not be structured in a way that is useful for creating a machine learning model. So what we have to do, you have to structure this data by transforming it to clean, consistent data, and that is what we call it as the data pre-processing. Once the data is pre-processed, only then you can guarantee the performance of a good model. So I will be discussing this critical phase of machine learning, that is how you can structure and transform the data that you gathered from various data sources to a meaningful pattern used by a machine learning algorithm. Okay. So in a data pre-processing, the first thing which we do is we split the data. Okay. Original data set is whatever the data you gathered from various data sources. It may be using some Google surveys, or it may be from hospitals, it may be from educational institutions. Wherever possible, you will be gathering the data, and we call it as the original data set. And the first step what we have to do is you have to partition this data into two partitions. That is the training data set, and the second one we call it as the test data set. And it should be done before applying the data pre-processing, because to overcome the problem of data leakage. So let us see what is meant by data leakage. When you are filling the data, missing data, or it may be the irrelevant data in your data source with the test data, what happens is your system is already seeing this test data. So it will impact the performance of the model, and you may get the misinterpretations which will fail the model in the real-time scenario. So first thing we do is we will be training the data, we will be testing the data, we will be validating the samples, then it is used for the algorithm. So the first thing is data cleaning which we implement. Data cleaning is how we handle the missing data, how we handle any null data that we have in the data set, and how to fill that data before giving this data to a machine learning model, before feeding it to a machine learning model. Okay, we have various techniques here. You may implement list-wise deletion. That means remove entire samples in your data set which is having the null values. Then you may go with a pair-wise deletion. That means you are using only the available meaningful data for your machine learning model. Or the second important way we have is the imputation methods. That means you are filling the null data with the mean of that detail, or you may be filling it with a mode of that detail, that feature in your data set, or you may be filling that value with the median of that detail in your data set. You are replacing null value maybe with the mean, maybe with the median, or with a mode, or sometimes we go with the most default value that is seen in the data set. We call it as the constant value replacement. Okay. Then we have a few advanced methods to work with this one. That is, we may use 10 nearest neighbors for imputation, or you can go with a multiple imputation by chained equations. So what are we doing in this space of data cleaning? We are trying to replace the empty data with some mean data, median data, or some default value, or any using any distance metric to fill that value. Okay. So once data cleaning is done, let us see how the data will be. For that, I will be showing a code snippet here. Two libraries are used here, that is pandas as a PD to perform the basic data manipulations. Then we have from sklearn.input we have a simple imputer, okay, which is used to perform mean, median and mode replacement for the null data that we have in the data set. So to show you an example how this null data is replaced in the data sets, I have taken a data frame here which has 4 columns, that is the name of a person, age of a person, purchase amount he spent and when did he purchase an item. 4 details or 4 features we have in this data set. And 5 samples of each detail is there. For example, a name, we have 5 details. John, Jane, Jack, John and none. Okay, our task is how to work with this none value. How to work with this none value before feeding this data to a machine learning model. Okay, for that purpose, what am I using? A simple imputer using a mean, that means calculate the mean of all the samples that we had in this data set and transform so that it becomes consistent. So what am I telling? In age and then a purchase amount column, implement what? It mean strategy and transform the data. Fit underscore transform is a method which is telling that on this data frame named data, there is a column age and purchase amount. Okay, you have to replace it with mean of that data. So, and also remove any duplicates that you have in the data set. So now you can observe when you are printing this data after a mean imputation, okay, there is John, Jane, Jack and none. Because on name column you did not implement this one, so that is not affected. And if you look at age, it is 28, 34, 28 and 22. See, this none is replaced. This none is replaced and it is not displayed. That means the data, whatever you have given input, inconsistent data is cleaned and transformed, which can be useful now. Then the second one we have, how to handle the categorical data in your data set. Okay, categorical data may be any text data that you have in the data set. But if it is transformed into numeric features, it will be more useful to get the better interpretations by the model. Okay. So for that we have 2 techniques here, label encoding and the second one is one-hot encoding. Encoding is transforming the text data to numerical values. Let us assume that there is a column called category in our data set and it has 3 distinct values, that is red, green and blue. Red, green and blue. So when you implement label encoding, what it does is for every distinct value that you have in the feature, it will be assigned with a unique number like 0, 1, 2. Wherever you find some red in your data set, it is always displayed with a 0. Wherever you find green, it is with 1. Wherever you find blue, it will be transformed to 2. Then the second one, we have one-hot encoding. Here what is done, for every distinct value that you have in the feature, a separate column is created and in that sample, in that record, if its column value is red, then only in that column you will be representing it with 1 and for the other values it is represented with 0. Same here, if a sample is having a color as a green, only in the green column it is represented with 1 and the remaining it is represented with 0. So what we call this way of transforming the text data to numeric format, we call it as label encoding and one-hot encoding. Okay, here is the code snippet how to implement one-hot encoding. Again, I'm using a label encoder here. We have a data frame where we have a data in 2 columns. Then I'm saying to implement one-hot encoding. So what am I writing here? pd.dataframe using which encoder? One-hot encoder. Transform a column named category. Transform a column named category. If you can see here, category is in a text format A, B and C That means I want to display this information in separate columns by A, B and C. And A should be represented with encoded data. A should be represented with encoded data. So now wherever you find A, it is represented with 10 here. Wherever you find B, it is represented with 15. Wherever you find C, it is represented with 20. Okay, transforming test data to numeric format is another way of handling inconsistent data. Okay. Then the third way we have that is feature scaling. Scaling means what? You are putting everything, every detail that you have in the data set, every feature that you have in the data set on the same level. May it be from range 0 to 1, or you want to make a mean of all the data values to 0, standard deviation of all the values to 1 and so on. So what are we doing here? We are using distance calculations, okay, to avoid the dominance of one feature over the other. For example, one feature in your data set may be ranging from only 0 to 1, values are only from 0 to 1. And there is another detail in your data set called salary of an employee, which is ranging from 0 to 1 lakh. This 0 to 1 lakh should not dominate the feature which is having values from 0 to 1. Okay, for that purpose, what we implement data scaling. Okay. And in data scaling, we have various techniques like a standard scalar, then we have a min-max scalar and so on. Okay, here we are discussing about the standard scaling and min-max scaling. Okay. So, standard scaling is a way of organizing the data in your data set such that every detail in the columns mean is equals to 0 and the standard deviation of the details that you have in the column is equals to 1. What are we doing? Any detail, any input that you have in this column, you are transforming in such a way that when you calculate the mean of all these transformed values, it will be equals to 0 and the standard deviation of all the values will be equals to 1. If you can see here, original data is 10, 20, 30, 40 and 50. Okay. And using the formula, for example, if you want to transform 10 using standard scaling, what we do? 10 minus mean of all the values is 30 by standard deviation of all the values is some 15.81. Okay, the calculated value is given as some minus 1.26. Like that, you are transforming 10 to minus 1.26, 20 to minus 0.63 and so on. Once it is transformed, now if you can calculate minus 1.26 plus 1.26 get cancelled, minus 0.63 plus 0.63 get cancelled, plus 0 by 5 is 0. Okay, so what is the way we used to transform these values? You are making the mean of all these details to 0. And if you calculate the standard deviation of all these transformed values, it will be equals to 1. So this way of replacing the details, we call it as standard scaling. And if you look at min-max scaling, again the input data is 10, 20, 30, 40 and 50. So how will you transform here? X minus minimum of X by minimum of X minus minimum of X will give us the data that we have to transform. If you look at the first sample, it is 10 here, right? So 10 minus minimum of the samples is 10. Maximum value in the samples we have 50 minus minimum of all the samples it is 0. So 0 by 40 which is 0. So 10 is transformed to 0. Same formula when you implement 20 is transformed to 0.25 and 50 is transformed to 1. All the details in these columns are represented within a range of 0 to 1. That we call it as standard scaling and min-max scaling. Let us see programmatically how it can be implemented. Here we have a data frame where we have two columns, height and weight of a person. Then I want to transform it using standard scaling. That means I'm importing the library called standard scalar from sklearn.preprocessing. Then you are asking fit underscore transform which data? This data using standard scalar technique. And and save that transformed data in this variable named scaled underscore df. When you are printing the scaled underscore df, you can observe the change. 150 is transformed to minus 1.4. 160 is transformed to minus 0.7. Likewise, all the details are transformed in such a way that mean becomes 0 and standard deviation becomes 1. Okay, then this is the code snippet for min-max scaler. Same thing. Same data, height and weight of a person. You are initializing it to min-max scaling and asking to transform this height and weight of a person using min-max scaling. That is what you are using. Fit underscore transform is a method which is used to apply this min-max scaling method on the training data. And it is again stored in min-max underscore df variable. Okay, if you can observe when it is transformed, now height of a person is transformed in such a way, its value always ranges from 0 to 1. Weight of a person always ranges from 0 to 1. Okay, this way of making every value to lie within the range of 0 to 1, we call it as min-max scaling. So this is about data scaling which we use in data pre-processing. Then comes the data reduction. Okay, that means for example you gather the data from various data sources. Then let us assume that there are some 100 details for each sample, and these 100 details may not be useful for your purpose, for your application, for your target. So you will be making use of only the necessary details, and those necessary details are also cleaned, transformed and prepared. So removing irrelevant details while preserving the essential details or the essential information for your target, we call it as the data reduction, simplifying the data set by reducing the number of features that we have in the data set. We call it as the data reduction. Okay, for example, we have 3 features here, feature 1, feature 2 and feature 3. Then we have the target, that is the dependent variable in your data set. So using chi-square test method, you want to choose any 2 best features to create a machine learning model. That is what we are mentioning here. Using chi-square test, use any 2 best features. Then fit underscore transform this data, whatever the input data frame you have. It has feature 1, feature 2, feature 3. Transform it to any 2 best features. Okay, so we have a principal component analysis is the method which can be used for dimensionality reduction. Same thing is initialized here. Fit underscore transform. These are 3 features used in principal component analysis. And you want any 2 principal components to be displayed in your data set once it is transformed. Okay, if you can see here is the reduced data using PCA. And here is the data that you have. That means only 2 details out of 3 details are taken to create a machine learning model. And this way of reducing the number of dimensions in your data set, we call it as data reduction. Then we have data integration. As we were discussing, you may not be getting the data only from a single data source. There are various data sources, and a few details from each data sources may be required to train your model. For example, we have 2 data frames here. The first one is customer ID, name and age details you gather. And there is another data set where you got a customer ID, purchase amount and the purchase date. Now you want to combine these 2 data sets from multiple data sources, and you want to create a final data set to feed to a machine learning model. In such cases, we use a data integration method. So what are we telling? We have a merge method in a pandas, PD, which is alias for pandas. You are telling merge data 1, which is the data frame 1, and data 2, which is the data frame 2, on customer ID. Using which key? By looking at the customer ID, you want to combine. So, and print the merged data. See, customer ID, name, age, purchased amount and purchased data mentioned here. So, we call it as the data integration. So all these things, whatever discussed till now, are the most critical steps we use before giving the data source or the data set to a machine learning model. We call it as a data pre-processing stage, where you will be using the useful data to create a machine learning model. Without pre-processing, what happens? Data is not consistent, data is not clean, data has many details, data is not scaled, so it may not be useful to extract the meaningful patterns from the data. So to make a machine learning model learn the real patterns from the data set rather than learning from the noise, we use this critical phase of machine learning workflow called data pre-processing. So all these are the different techniques we have for data pre-processing. And then whatever the consistent data you get from this step can be used for feeding a machine learning model. Hope I discussed all the phases of and all the steps in data pre-processing. Thank you.